Now we're going to be moving on to solving problems involving similar triangles. So we started with trying to determine whether triangles were similar by using angle, angle, side, or side, side. Now I'm telling you that these triangles are similar, and we're going to try to find a missing value. And what you want to do is match up the different corresponding sides and make ratios. So I've already marked which angles are congruent to help you out on these top problems. So I have 3 over A equals 5 over 15. And then I'm going to cross multiply to get my equation to solve. So 3 times 15 is 45 equals 5A, and then divide by 5, so A equals 9. Your scale factor is what you're multiplying by to get from one triangle to the other, and it kind of depends on what my perspective is. So if I think about going from 5 to 15, I'm multiplying by 3, so my scale factor would be 3. You can also get it by dividing the sides, so 15 divided by 5 would be 3. But if I changed my perspective from going to the big triangle to the small triangle, it would be a scale factor of 1/3. So it matters which direction that you are looking. Looking at our second set of triangles, I have 20 over 12 equals 15 over B. So I have 20B equals dun, da, da, da. Helps if you have your calculator ready. 180. So B equals 9. And if I wanted my scale factor, I could reduce this 20 divided by 12 or do 12 divided by 20. So if I reduce that, I would get divide by 4, so I get 5 over 3. So 5/3 or 3/5, whichever direction you're looking. We're going to skip the word problems and do those in class and go to the back. So these are 2 more theorems. The first one is the triangle proportionality theorem, and then the converse is the second one. So the first one gives me that the 2 segments are parallel to each other. That means that then RT, I'm going to use some of your favorite color coding, over TQ is equal to RV over VS. So if I know that those 2 segments splitting the triangle are are parallel, then those specific segments are proportional to each other. The converse flips that. So if I know that RT over TQ is equal to RV over VS, then we know they're parallel. Remember our converse, inverse, contrapositive that we did. So if I want to use this in a problem, it's asking me what RQ is. So they gave me in the words of the problem that I didn't type out that those 2 segments are parallel to each other, so that means I can use the triangle proportionality theorem. So I'm going to put X over 9 equals 4 over 6. So 6x equals 36 and x equals 6. Looking at this one, they gave you that it's parallel, and I'm just going to call this, there's a lot of y's and z's, let's just call this A. So 44 over 35 equals 36 over A. We have some large numbers here in this problem. So when we cross multiply, we get 44A equals 35 times 36, which is 1,260. But when I divide that by 44, we get a lovely decimal. Wonderful. So sometimes decimals happen in life, and we'll just go to one decimal, which is 28.6. Okay, now the next one is asking whether these two are parallel. So if they were parallel, it would mean that the proportions were equal. So 50 over 90, we want to know, does that equal, so I'm just putting a question mark, 40 over 72. So the left side, what I want to do, since I don't know they're equal, I don't want to cross multiply. I'm going to reduce the left. That reduces to 5/9. And then let's see what I can reduce the right side to. So 72 is divisible by 8, so let's divide both by 8. So we get 5 over 9. So yes, they are parallel. Not 11, parallel.